SV Math Teach here, today talking about volume of spheres. You know, before we actually talk about the volume of spheres, let's see if we can draw a sphere. A sphere is just a circle that's been made into 3 dimensions. Oftentimes you're going to see it look something like this. That's our version of a sphere, where you have the center, and then from the center out to any edge, it could be that one, or it could be this one, or it could be this one for that matter. All of those are your radius. So a sphere only really has one measurement. Heck, you could even argue that the height is really just the radius times 2, or the diameter, right? Because the only real variable in a sphere is the radius. So when we come down here and look at the formula, by the way, subscribe. When you look at the formula for the volume of a sphere, the only variable is the radius. That's it. 4/3 pi r cubed. Cubed because we're dealing with volume. So look how easy this can be. Find the volume of a sphere with radius of 2, and we'll do the exact and approximate again. So the formula is 4/3 pi r cubed. And your r is 2 centimeters, so it's 4/3 pi 2 cubed. Now 2 cubed is 2 times 2 times 2, that's 8. So I have 4/3 times pi times 8. And I'm going to multiply 4/3 times 8. That's going to give me 10.6 repeating, or 32/3, depending on how you like it. So I'm going to go with 32/3 pi. If you prefer decimals, 10.6 repeating pi. Those are both exact. So I'm going to go ahead and say either one of those would count for my exact. So 32/3 pi, or 10.6 repeating pi. And I need my symbol, or my units, centimeters, so centimeters cubed. Right, both of those would need a centimeters cubed. So this is the fraction version. We got that just by multiplying 4 times 8. That's 32, and then third stays on the bottom, right? 32/3. Or I showed you the calculator version. Like in every other video, if you want to get the approximate, which is the second answer, to get the approximate, you just take your 10.6 repeating, which I already have in my calculator, and multiply it by pi. Or the approximation of pi, 3.14. So now I get 3.397, so 3.4, because that 7 makes the 9 go up, and the 9 makes the 3 go up, so 3.4 centimeters cubed. That doesn't make any sense. It does make sense because 10 times 3 would be 30. So 3.4, oh, I hit divide. So let's try this again. 10.6 repeating times 3.14. That looks better. Okay, good. All right, so we got 33. I hope I said the right thing, but I typed the wrong thing. 0.49 centimeters cubed. Okay, so we have the exact and the approximate. Next one, find the radius. I think this is it, right? Find the radius of a sphere. So this is really all the other thing we can do. Now, this is a work backwards problem where you still start with your formula, and then you plug in what you know. We know the volume is this, 288 pi. So they gave us an exact answer because we have the pi in there. So 288 pi is 4/3 pi r cubed. All right, so like in every other video where we want to solve for a variable, I'm going to go ahead and divide by the things that need to go away. On the right-hand side, I divide by 4/3 pi. I'll do the same thing over here. I'll grab my red pen because I like to cancel out with red. 4/3 divided by 4/3 cancels out. Pi divided by pi. Pi divided by pi. And then I have 288 divided by 4/3. I'm just going to use a calculator for this. 288 divided by, I don't have a fraction button, so I'm going to divide by the parentheses, 4/3. That'll do the same job. And I get a nice even 216. So 216 equals r cubed. And I hope you've memorized your perfect cubes. If you have not memorized your perfect cubes, you're going to have to lean on your calculator. And quite frankly, to do that, you need to use the cubic root, because the cubic root is the opposite of the cube of something. So I'm going to get radius equals, and I need a little bit more calculator here. So I'm going to look and see if I stretch it over, if I get more. No, I'm looking for this cubic root of 216. There we go. So cubic root of 216 is 6. All right, so with that in mind, Radius is 6. We're in centimeters. So centimeters and done. And you notice how it came out to be exactly 6 because we haven't ever rounded. So we go ahead and say the radius is exactly 6 centimeters.